right, we are back after taking a few days off. Um, I will admit to being a little frustrated by how day 16 has gone so far. I think we've gone down an interesting path, but I wanted to take a break from it, to step away, and to try to get some fresh eyes. And in some sense, I cheated a little bit, or it would be cheating if I were actually competing in this. But I did get a hint from somebody who pointed out that I had completely missed a pretty key idea in this puzzle by not looking very closely um, at the puzzle input, the actual puzzle input. So when I looked at the puzzle input, I went, okay, there are 55 of these valves, and again, if you weren't here, the problem is basically there's a network of tunnels. They're labeled. Each tunnel leads to other tunnels, and we can open a valve, and it will let some amount out of this tunnel every minute. Takes a minute to open a valve, takes a minute to go between valves, like to follow each tunnel. In 30 minutes, what's the most pressure that we can relieve? And what I failed to notice was how many of these are 0. And that's kind of a big hint. And I'm a little bit mixed. Part of me thinks that the puzzle input shouldn't have. Well, I'm tempted to say, and I think I don't agree with this, but I'm tempted to say that the puzzle input shouldn't the shape of the puzzle input should matter for how you solve the problem, obviously. But this seems very specific. The fact that only 15 of these are actually have flow rates, very specific. And I didn't notice it at a glance, and I think it's totally fine that that's the shape of the puzzle, and I think I missed something, and that happens. That's why we take breaks. That's why we talk to coworkers. That's how we learn from that. So I'm not too bitter about it, but I'll admit to being a little bit frustrated. Because once you recognize that these have only 15 of these have flow rates, it kicks off another leap, which is, okay, can I model this as only 15 things that matter, basically? And that leads you to, and by the way, I guess I did notice that several of these were 0, but it's not that close to the same proportion. Like, only 5 of these are 0, and I think I just kind of projected. Anyway, so then that immediately triggered me to think, well, actually, instead of having each move, like we have move somewhere in here, be either open or walk somewhere, the only thing that matters, the only thing that affects the problem, really, is when you open something. And there are only 15 places that you can open something. And so the only real move is go to one of these 15 places and open it. And in order to do that, you're always going to take the fastest path to get there. So if you know the fastest path between each one of these valves, now you've got a graph that's got weighted edges that tell you how the shortest distance to get there. It takes you that long plus a minute to open it, which is fine because you can actually just make the wait 1 greater than it otherwise would be. Is that true? I believe that's true. And then the question is, then it's basically a trolley salesman problem, right? You have 30 minutes, and you have to figure out how you're gonna traverse the graph from AA and you're done. And and I guess the other thing is like figuring that out. Like traveling salesman problems are non-trivial. You have to solve them somehow. But on 15 nodes, it seems like the pretty naive, depth first search type thing is going to work pretty well, or breadth first search. I guess I'll have to think about which one is which. So I think basically came at this the wrong way. Missed a pretty big fact about this problem, and I think I kind of also prematurely optimized in the sense. So I definitely thought about just going. I had this idea that it was going to be working backwards, right? Which is how like game solvers typically work. And I think there is something there, and I think it probably could be used to improve the runtime of the algorithm. But I thought I needed that because, look, I mean, a graph of 55 nodes, it's going to take forever to search the whole thing. 55 factorial is a gigantic number, and obviously it's not going to take that long, but it's going to, like, not be, it's going to be some big number factorial or something that we're going after. And so I thought I needed to optimize, and I couldn't just brute force it. But with 15 nodes, I think we can just pretty much brute force it, I suspect. So this is all fine. I mean, again, it was somewhat frustrating, but the point of this is to learn. It's for me to learn. It's for you to learn. And sometimes learning is hard fought. And one thing I learned, because I thought about this problem a little bit, and I did some research, and I didn't know a good algorithm for figuring out the shortest distances in a graph. It's just not something that ever came up in any problems I was solving. And so I got to learn about the Floyd somebody, starts with a W. Floyd, hang on. Floyd Warshall algorithm, which is a really cool algorithm that I didn't know about. And we'll get to use it here. So, okay, let's strip everything down and apply our new idea. And that's going to involve getting rid of a lot of stuff. I'm going to git stash this. Am I going to git stash it? Yeah, I think so. Well, I guess I can just check out branch. Let's call it questionable attempt. Stashing questionable attempt. Now git checkout. And okay, well, that's not going to work for us. So I guess we will merge from. Yeah, this is why you should commit more. I'm just going to merge this into main. And okay. Git checkout main. Oh, we're already main. Git pull or git main. We should get everything back. Okay. So I'm gonna get rid of a lot of stuff. Getting rid of all of this. Getting rid of all of this. spec. I don't know. Might need that. Might need that. Yeah, so I was trying some stuff that we're not going to need. Started implementing a solver that we might need, but we'll rewrite it if we do. We're not going to need move. We're going to use valve graph, but it's going to be different. So a bunch of stuff is going to disappear from that. We will use valve. We will use all of the parsing stuff. I don't think we're going to need valve graph state. And okay. And probably some of our tests aren't going to matter. Get rid of these. Let's get rid of that. Whoa. Valve graph initializes we'll use, but we're going to make it something else. This doesn't matter. Parsing still needs to happen, but the valve graph is going to change. This doesn't need to exist anymore. And okay. And now lots of stuff doesn't work because we don't have moves anymore. So none of this stuff is really going to matter. None of this stuff is really going to matter. Get neighbors will matter. Length will matter. Okay. So things compile. And okay, and our tests are still passing. Cool. I mean, not the two that actually test the problem, but the rest of them. Okay, so we need to update. We need to update the valve graph to. Yeah, I think we're going to cut a lot of the valve graph also. So the valve graph really just needs to be really needs to know the distance between different nodes. So let's we need what? We're gonna need something like recursive graph. Neighbors is fine, but we're gonna need get distances also. So get distance AA DD is 1. What about like AA to FF? So AA goes to AA to AA should be 0. That one's probably important. what's one that's hard to get to? So you go from AA to BB to CC to DD to EE to FF is 5. Can you get there any faster than that? Also, there's a question of whether we want to call that. Yeah. That's the distance. So the alternative would be to go to DD first, which you could do. In which case, it would be 3, because you go DD, EE, FF. And if you tried to go II first, then you would have to go to JJ. II wouldn't even work. So 1, 2, 3 is the distance to FF. AA to FF is 3. And if you wanted to get to JJ to FF, you would go II, AA, and then it would be 3. So 5 total. Because you have no other options. So JJ to FF would be 5. And let's just make sure that things are symmetric. JJ. Okay, and so in order to do that, we're going to want to compute the distances from the get-go. So let's go excuse me. Let's say distances for now will be a hash map from string to usize. And here, hey NetFreaks, thanks for the follow. What do I think of PHP? I used it a long time ago to build a website. Back, it was in like 2010. It was before Laravel and all of that good stuff, before web frameworks. And to be honest, I didn't understand what I was doing in a lot of ways. I kind of learned by doing, and was working with a friend of mine who was a lot more experienced than I was, so he was leading me through it. So I thought it was fine at the time, but I really haven't kept up with PHP since, and so I don't have super strong feelings about it. Is it bad now to study PHP full stack? I don't think it's bad. People still do it. There's a good podcast. I'm blanking on the name of it now. It might be just called Full Stack Podcast. It's something like that. And the guy who does it is a big Laravel guy. Laravel and PHP. Let me see if I can figure it out. I think it's called Full Stack Radio. Yeah, Full Stack Radio. So, I mean, there are people on Twitter who talk about it. My feeling in general is, like, you should use the tools that feel good to you and learn as much as you can. And then when you go and interview places, it shouldn't really be the tools that drive it. It should be, the companies you want to work for, the types of problems you want to solve. And if they're using a different product, then you should, like, have the understanding to be able to switch over if you need to. It is somewhat difficult to get a job without a degree, without a college degree. I think it's getting easier, but at least in the U.S., I think it's getting easier, but it's still hard. The problem is mostly, like, I think a lot of companies, if they interview you and you do well and it's clear that you can, you have the chops, then it's not that big a deal. Then they'll hire you because it's hard to find good developers. The trouble is that you won't tend to get in the door because they have a lot of people who are applying, and they have to have some way to filter down to a reasonable number of people to interview, and that's hard to do. Like they just have to pick certain heuristics. And one of the heuristics is like you have to have a degree. Okay, so let's say let distances be self compute distances valves, and that's where we'll use Floyd, whatever it's called, I don't remember the name of, and compute those distances. And I'm just thinking about whether we need to maintain the ordering anymore. One reason to have an ordering is to be able to track which valves we visited easily. I don't know. I'll think about it. Okay, let's compute distances. So, get neighbors. Let's do it here. Let's do it below length. Compute distances. And that will take a vector of valves, and it will return a hash map from the two valve labels to the use size. And there's a real question. Do I want to instead just index these by, I think, okay. Okay, and so the idea behind the Floyd, whatever it is, algorithm is that if you know the shortest distance that doesn't include some point, so if you take a subgraph of your network and you work out what the shortest distance is in that subgraph, and then you add one more node into it, the paths that go through that new node can only be shorter or the same as through the previous graph, because either that new node helped you or it didn't hurt you, right? You knew the shortest distances, so you're going to detour through it to get a shorter distance. So either it helped you or it did nothing. And if it helped you, then the path always travels through that node, which lets us recursively calculate. We can start by just considering the graph of one point, essentially, and then recursively calculate the shortest paths from there. So the first thing we're going to do is filter down to just the valves that actually matter, which in fact I think we should do immediately. Although it's weird because valves AA doesn't actually have. Should we do it immediately? I guess not. I don't want to calculate the distances over everything though. Like we have 50 some odd different valves. I guess we need to calculate the distance over everything actually, because some of these flow rate 0 valves could still be the only possible path between 2 points. So I guess we won't filter down. So we're just going to do a recursive thing where we're going to say we're going to instantiate the graph to have the distances be infinity. Let's see here, how does this work? I'm doing this from memory, having read about it a few days ago, because I want to make sure that it's actually instantiated in my brain. So the idea is going to be to have some distance function that's like distances on, or just like get distance on subgraph distances, which says if you go from one node to another node, only allowing the first n nodes to be considered, then it returns a distance. And the idea is that this distance, the idea is that this function on I, j, k is always the minimum of ij k minus 1 and dikk plus dkjk. Am I doing that right? So the idea is that when you go from, I think for the sake of ease, I'm going to do these as usize, index them on usizes, just because it helps me think. So adding a new node to the subgraph you're considering is either equivalent to the previous version, or it's the shortest path from I to K plus the shortest path from K to J. That's the idea. That seems right. That seems right. And so we can say, we can instantiate the distances to be 1 if nodes are adjacent, if they're neighbors, and infinity if they're anything else. And then recursively allow n to grow. Yeah, something like that. So it's like, let me distances be and 0 if they're the same. So let's see here, 0 through I. Not I, but balanced out length. So we'll say n nodes, balanced out length from 1 to the number of nodes. Oops. And then we'll zip that. Nope, can't zip it. I guess we have to go through all the permutations. Of ij and k, or ij and n, whatever we want to call it. Yeah, let's do that. So I think there's a way to get permutations, Rust permutations. Done this before. Iter tools, permutations. And I guess we have to import iter tools. And okay, now it's happy with me. And so we're going to say permutations is going to be 0 through n nodes dot intuitor dot permutation. How do I get the permutations? Dot permutations. Takes a self, takes a iterator. Okay. Permutations 3. Cool. That gets us permutations. And then, so then for each of the distances, for each permutation, what to say. We need to recursively we're going to calculate the distance from I to j as the minimum of those distances. How do we know that we hit every... Can we just do this? For ij, k in permutations. And I'm gonna make these U sizes. Let me distances be a hash map. And distances ij is say let candidate let old distance be distances ij, let candidate be distances ik plus, oh, these need to be get. And we'll have to map these. Plus distances kj. And yeah, the compiler's unhappy with us, that's fine. Then we'll insert let new distance be if candidate is less than old distance candidate, otherwise old distance. And we will insert new distance. And at the end of this, we will return distances. Okay. So, permutations, we have to collect this. Yeah. Okay, so now the issue is it needs to be instantiated with something in the first place, which I think can just be .map Actually, I want to map none. I want to map computes a default return function if none is what I want. Oh, I don't need to map the value though. Or else. That's what I want. And this will be secret dot or else. And this will be if I dot no if valves I dot get neighbors contains valves j dot get label, then one else if valves, I guess maybe first we should say if I equals j, then 0, and then else usize max, basically infinity. Expected an option. Returns the option if it contains a value, otherwise. Okay, sum. And then we'll unwrap because we've guaranteed. And let's see if you're here. I don't want to borrow it. I guess I can though, and then cloned. Okay. And valves I. Wait, why don't we know what valves I is? Valves I is just is a valve. Not sure why we wouldn't know what that is. Distances. Okay, so this should be something's going a little wrong with the okay. Contains valves get label, presumably needs to be borrowed. Okay. So now and candidate so this has the same problem. Do I want to just instantiate these from the get-go? And also, how am I guaranteeing that these all get visited in an okay order? So so let's say let edges be 0 and nodes into iter permutations to collect. And then distances can be edges into iter map ij, and we'll just take this. It's just this. This should be a back of usize. Wait, what? That could type usize can't be built over elements of tau. Okay, dot map v dot 0, v dot 1, v of 0, v of 1. Okay, and then here we just need ij 0, ij1, and ij usize max. Collect. Okay, so that instantiates. And so now is it sufficient to just go through the permutations? My worry is that it might not be. Because you might be able to have some weird case where I feel like the order in which you visit them matters. But okay, we'll deal with that when we see our tests failing. So now this can just be this, and we can say unwrap because it's guaranteed to exist. We can say unwrap here also, and we can say unwrap here also. And we can dereference this, and those two add anyway. And we need to insert the key ij new distance. Okay. And permutations needs to be known to be usize, usize, usize. And we need to map it. Wait, why is VAU so right? V1, V2, V3, usize, usize, usize. Value of usize, yeah, it needs to be a vector. Okay. Okay, so this ends up not being necessary. And we'll just want to test that, and then this will be distances. We'll just make this usize, 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 and then get distance, label, option, usize will be self.distances. Get self.ordering. So let's actually say let I be self.ordering.get label. Let J be self.ordering.get not get label. Get say I label and J label, or from into would work also. If I is none or J is none, return none. Otherwise, we get from I.unwrap and J.unwrap. And option usize. All right, and what else we got? Valves is now a problem because it's been copied somewhere. here. And these are a problem because they can return nuns. We will just unwrap them for the test. So I don't think this is going to quite work because I don't. Yeah. So the issue. Oh. Yeah. Okay, that's a fair point. That's a fair point. So this is going to add with overflow. So, I mean, I can just make this a sufficiently big value, but that's not quite so big. So let's just say distance bigger than max. And we can probably just use like 1,000 or something. Yeah, I mean, 1,000 is going to be way bigger than the next value. Const distance bigger than max. 1,000 is fine. Okay. Fails because we're getting a none here. But the only way we get a none here is if distances is if the labels don't exist. But the labels should exist. Label string usize, we take valves, we enumerate it, we throw the label in there, size, and that's ordering. Why would this not exist? And that's the only way that happens, right? Get distance. Distance.get. No, it could also happen if I and j don't exist. Here we should panic. Expected option size. Oh. Weird. Okay. I want to expect if the labels exist, they should already have distances computed. Okay. Yeah, okay, so that's not working. Which means compute distances isn't working. And yet distances for every node index does a computation. it should be getting instantiated here. Our permutation's not inclusive. All K permutations. Yeah. Okay, that's what happens. That's fine. So this never happens. And then when we do get distances, though, which is somewhere, get distance, we need to say else if I equals j, return 0, sum 0. And this now is number of nodes minus 1. Which, okay, we probably don't need this anymore. Whoa, it passes. Fascinating. So, that means this just works. Which is pretty cool, but I'm surprised. I'm surprised because I would have thought that that we could wind up in situations where we haven't computed it yet. I guess K is uniformly increasing. And so we're starting at K equals 0. Like whenever we're computing ij k, we've already computed ij 0. Have we already computed kj 0? Seems like not necessarily. So it seems like we want to make sure that we've done all of the k's first, and then the i's and the j's. Because otherwise I'm not sure. I mean, the test is passing, but I'm a little skeptical. Might still work. I have to think about it. Okay. Say we go through the k's first so that we solve all k equals 0, then k equals 1, etc. recursively. Okay, so now we can get all the distances. And now we just need to search the space. So let's say something like Get maximal path. Self. Time. Maybe t remaining. We need to know what's already been visited. So visited. It can be a hash set usize. And max so far. It can be a usize. Maximum flow. And current position. Return to usize. And then this is if time remaining equals 0. Then we return max so far. Max so far, or let to return be max so far plus recursion result. Return max so far plus recursion result. And to do the recursion, we need to say let current valve be self dot, it's just self dot valves, current position, and let recursion result be current valve dot get neighbors dot into iter dot map. Let's get the self dot ordering s dot unwrap. That gets us the indices. Wait, we don't want the neighbors though. We want I guess we just want to pass around unvisited. Say unvisited here. And then this becomes recursion result is unvisited. Some node, and what to say here? Self.get maximum flow of time remaining is going to be self.get distance current position to n. That's going to be time remaining minus that minus 1 because we have to actually open the thing. Current position is going to be n, and max so far is going to be max so far plus the current flows. Let new max equals max plus self.get let's see here. We need all the visited ones then. But we can just do self.get cumulative pressure. No, self.valves current position dot get cumulative pressure from time it's not say get cumulative pressure over time remaining. So far. Yeah. And then this becomes new max. So the idea, and this should be new max also. So the idea is we check if we're just done. If we're done, there's nothing to do, we return. If we're not done, we go through all of the unvisited values. Or if we're not done, first we add do I want to do it here or do I want to do it? I think actually let's not do let's not do new max here. Let's do max so far plus self.valves n dot get cumulative pressure over this thing. And for that, let's say let's say let new time remaining be this. Self dot time remaining minus self dot get distance. What's the issue? Self dot get distance. We just unwrap. Self.get distance returns an option argument to the function are incorrect. Sure. We can just say distances dot get. And then here we need to filter n doesn't equal current position. And actually, we should call this new unvisited. Call this new unvisited. Okay. Okay, and then this could be there. And that's new unvisited. This becomes new time remaining. This becomes dereferenced. This becomes dereferenced. And we need to implement cumulative pressure over, which we will do. We need to collect. Wait, why do we need to collect? We don't need to collect. We need to max and expect there should be at least one unvisited. Should there be at least one unvisited? I guess we could say or unvisited.length equals 0. Okay. And then cumulative pressure from get cumulative pressure over time remaining time. And this will be, I don't want this here though. I want this as a function on valves. So that is open, then time remaining as U32 times self.flow rate equals 0. Okay. One thing is we don't need to visit anything that, I guess we'll do our filtering external to this. So get cumulative pressure over. Sure, let's make this a U32. Let's make this a U32. And time remaining. This is actually time remaining. Wait, hang on. Current valves that are used. Not sure what the issue there is. New unvisited. Sure, I mean, this can be a reference. We shouldn't need to copy it all over the place. New unvisited filter. Okay, bar checker stuff. And so now I just want to make sure I'm being apples to apples here. So the new stuff should be max so far is going to be 0 at the beginning. No, yes, max so far is going to be 0 at the beginning. We will not have computed anything. So new unvisited removes the current thing that we're visiting. So we need to add current position here. time remaining. I don't love this. Yeah, unvisited should already not include this, is my feeling. So let's get rid of that. This is just going to be unvisited. Which means that new unvisited is going to be unvisited iter cloned filter I isn't n, collect, should be a hash set. New unvisited. And then next time remaining, good. And then the max so far should include the fact that we spent the time from current position so far. Should be self.valves, current position, get cumulative pressure over time remaining, and then new max so far. And then this should be new max so far, and shouldn't need that, which I think is equivalent to what I already had, but this helps me think about it. Okay. And now our test becomes instantiate graph and then graph.get maximum flow let unvisited or let nodes with flow be graph be valves dot into iter dot filter b dot get flow rate greater than or equal to 0. Collect into a hash set. So this becomes nodes with flow. Time remaining becomes 30. Or initial minutes until eruption. Current position is graph.getLabel. No, graph.getIndex. I mean, it's just 0. We just know that it is. And max so far is 0. Okay. And this should just be input. And this needs to be a reference. Oh, it shouldn't be a hash set of valves either. It should be valves. Okay, so I guess we'll actually say 0 through valves.length into iter valves I. Is greater than 0. Okay. And let's see how we do. It thought it failed. Oh, it didn't fail. We got an answer. Hang on a second. Oh no, we got the answer 0. But it ran quickly, but it also gave us the answer 0. So, okay. Okay, so probably just something with the recursion. Unvisited nodes. Let's jump into the debugger and see what happens. Okay, so the graph has distances. I can look up the different distances. I get answers. They look broadly fine. Nodes with flow, there are 6 of them, I believe that. Get maximum flow. Okay. Okay, so recursion is returning 0. New one visited. It's just all of the ones that aren't the current one. New time remaining is just less than time. So let's jump into one. Max so far is 0. Max so far is still 0. Time remaining is 27. Valve's current position is 2. 2 is C. C has a flow rate of 2. But it's not open because we haven't done anything with that. Okay, let's just be this. And let's rename this to be if opened. Okay. So now we have a proper failure. We're a little bit off the actual answer. Okay. So this one does nothing. This one, though, says so current position is 1, which is B. B has a flow rate of 13. 364 is what, 13 times 13 times 28. 364. New max so far. Oh, we need. It's gotta be max so far plus. Okay, so now we're way over counting. Okay, so we're at position 2. It's 2 per. It's 27 minutes left. Because it took us however long to walk there. 2 minutes to walk there and 1 minute to open. Two minutes to walk there, 1 minute to open. Is that right? BB, it should have taken us 1 minute to walk there and 1 minute to open. Distance between 0 and 1 is 1. Time remaining should be 30 minus 30. We don't subtract anything. 30 minus 1. It should have been 30 minus 1 minus 1. It should have been 28. Why is it 27? Why is time remaining 27? Okay, so we're at 0. Current position is 1. Time remaining is 28. So this is, we stepped to BB, which is logical. Max so far is 28 times 13. That seems right. We're not done yet. We're going to keep doing our depthwise search. By saying the new unvisited no longer has BB in it, and the time remaining should be 2 more seconds off of that. So it should be 28 minus 2, right? Assuming that we walk to CC next. New time remaining. Okay. So if we drill in, okay, we walked to 4. So 4 is EE. So we went from AA to BB to EE, which took an extra step. Because we had to go to C, D, and then E. So we opened 2 valves. We opened BB, and now we're opening EE. And we had to walk 5. So we should be at 6, right? Because we haven't opened it. 6 that's to 24, that's correct. But we haven't opened it yet. So it's time remaining. New time remaining. No, that includes opening it. That includes opening it. So this seems okay. So we're at A. We're at B. And now we're at F, which we know is distance from B. We have to go to all of them. So we've traveled distance 5. We've opened 2 valves. So we should be at, I would have said 23, or I would have said 23. Current position is 7, which is FF. To get there, we had to go 1, 2, 3, 4, because we came from BB, 5. So we've spent 5 minutes walking. We've spent 2 minutes opening things. That's 7. Why is time remaining 21? BB to FF is 1 to 7. 1 to 7 is 6. 1 to 7 isn't 6. That's not right. From BB, we go CC, DD, EE, FF. With the index, oh, sorry, we're going to H. We're going to H. Okay, and then we have to go 2 further. Okay. Okay, so that's correct. So step 9, we opened 2. I shouldn't, I'm double counting. I'm double counting next so far here. It's just the recursion result. It's just the recursion results. Okay, thought for a moment. And attempted to subtract with overflow. That's good news. Sort of. Okay, yep, that's fair. New time remaining. So, what to say about this? We should filter out the ones filter N where time remaining minus self.distances and all of this. Just clunky to have to say it multiple times. Plus 1 is less than time remaining. We only want it if it's greater than or equal to time remaining. Okay. So now there's a case where, sure. So let's return .max, .map, or .else. unwrap or. There we go. Yeah, because now we can be in a situation where there's nowhere we can travel. Isn't quite working. Self.distances dot get. The distances should be less than or equal to time remaining. Less than or equal to time remaining plus 1. Right. Attempted to subtract with overflow again. Distances plus 1. Time remaining. Okay. Thought for a moment. Hey, we did it. Oof. We did it, we did it, we did it. I think. At least the example passes. So 2156 is the putative answer. And 2156. Oh, our answer is too low. Really? 2156. Wait, fails? No, it passed. Most possible 1651. And this test is passing. The full input file, let's just check. 55. At the bottom, yeah, that looks right. At the top, that also looks right. The answer is too low. Oh, we start at AA, but AA isn't the first one in the list. Okay, we made an assumption here. Current position. So we need nodes with flow. Does AA have flow? Okay, it does not. So current position is not 0. Current position is And then up here, we need to put this. Okay. 2183 is the new answer. There we go. All right. Whew. That was a lot. So I'm kind of pleased because I noticed I was making that assumption, so I'm happy. If I hadn't noticed that assumption, it would have taken a lot longer to debug. Oops. Speaking of which, 2183 was it? So that was nice, just to be able to debug that quickly. Probably shouldn't have made the assumption in the first place, but hey. Okay, it is 3 o'clock. Let's just look. Nah, you know what? I'm going to start with part 2 next time. This is a good stopping point for now. But thanks for watching, and if you haven't already, please follow. And I will catch you next time, which will be either tomorrow or Thursday. I'm here every Tuesday and Thursday from 1 to 3, and I try to stream a couple other times as well throughout the week. So nobody to raid, so I'm just going to end. Have a good one, everybody. See you next time with part 2.